Hi, my name is Brahim, and in this course we will learn a language called mathematics. So if you want to learn a language, one of the first things, if you want to learn a new language and you want to learn, say, the grammar of the language, one of the first things you might do is focus on the parts of speech. So let's look at a certain aspect of the English language just as an example. So here's a perfectly grammatical English sentence. John hit the ball. And we can ask, what makes this grammatical? So suppose you're trying to describe the rules of grammar to someone who's learning English, and you want to explain to them what it is that makes this grammatical. Well, you would not focus on the meanings of any of the words. It doesn't matter who John is or what it means to hit or what it is that's being hit. If you want to just explain why this is grammatical, you really only need to focus on parts of speech. So focus on the fact that John is a noun, or proper noun, and hit is a verb, a transitive verb, and the ball is a noun phrase. And that's it. It doesn't matter what noun is here, what transitive verb is here, what noun phrase is here. No matter what you end up putting there, just the fact that you have these parts of speech in this order is enough to tell you that this is a grammatical sentence. So one of the rules of English grammar is that noun, verb, noun phrase in that order is grammatical. That doesn't tell you anything about the meaning of the sentence, and knowing the meaning of the sentence doesn't tell you anything about why it's grammatical. It's just a rule of the language, and to describe the rule, one needs to focus on these categories that the words fall into. So these categories are called parts of speech. And the set of rules that determines which sentences are grammatical and which sentences are not, that's called syntax. So our main question, or our main concern now is, what is the syntax of the mathematical language? Or you can think of this as asking, what is the grammar? What mathematical sentences are grammatical? So here we are trying to learn a language, mathematics. Our first question is just, what things can I say, what strings of symbols can I write down and have them, even be allowed, have them even be syntactically correct. So I hope you're seeing that to answer this question, we need to know about the parts of speech of mathematics. So what are the parts of speech in mathematics? And there's more than one way to describe the grammar of English. There are multiple ways to describe it that would lead to the same overall grammar in the end. Similarly, there's more than one way to answer this question and build up the mathematical language. But we're just going to focus on one way for the sake of this course. Let's talk about the parts of speech in mathematics then. So we've got constants, and we've got variables. So these are two parts of speech out of the four total that I'm going to describe. Constants, so maybe I'll relate them also to, well, let me start by giving you examples. So constants, things like 0, 1, 3, this symbol, which will end up standing for the set of natural numbers. This symbol, which you could say refers to the sine function. And here are some examples of variables: x, y, a, alpha, capital Q. These are all variables. Now, if you look at an English word, like John, how would you know? So what is the part of speech of this? It's a noun. It's a proper noun. So how would you know that? Well, you know it's a noun mainly actually by focusing on the meaning of it. The fact that the word John refers to something is a hint for you that this is a noun. It's the same with these guys. The symbol 0 is a constant partly because of what it refers to. So it's a symbol that just refers to a specific thing, a lot like proper noun, the proper name John. So maybe I'll just write this. Constants are like proper nouns. They refer to specific things. So like Germany is a proper noun. If you say Germany, that refers to a specific thing. If you say sign or 3, that refers to a specific thing. Variables, on the other hand, well, they refer to things, but what they refer to is really dependent on the context that they're in. So actually, these are a lot like pronouns. Like he, she, they. If someone says he in a sentence, then you cannot really know what the word he is referring to without knowing the context, either knowing the entire sentence or maybe even other sentences in the general context of that discussion. So proper nouns refer to things, pronouns refer to things. But proper nouns refer to specific things. What they refer to is always the same, is constant. And pronouns, what they refer to depends on context. It varies. So that's kind of a way to remember maybe why these are called constants and variables in mathematics. So these are 2 of the 4 parts of speech that I will describe. And I'm not listing everything. I'm just sort of showing you what might go into a full description of the grammar of mathematics. If we actually went through a full description, it would just take too long. So here are just some sample constants. And I've got a pointer here. Here are some sample constants, and here are some sample variables. But really, the full list of variables, I guess, would include all lowercase and all uppercase letters of the English language, some Greek letters like alpha, maybe letters from other languages. And the full list of constants, well, it would be a sort of large but finite list consisting of a bunch of, atomic symbols that refer to specific things. And you would typically grow that list, inventing new atomic symbols as you need them. So one thing that constants and variables have in common is that they refer to things, just like proper nouns and pronouns both refer to things. They're both nouns. So constants and variables actually sit in a larger category, not by themselves. And maybe I'll do a box. Of terms. So terms you can think are like nouns in general, or actually more like noun phrases. and you'll see in a moment why I'm saying that. So constants are terms, variables are terms, but there are also more complicated terms. And, well, what makes, if you want to know whether a mathematical expression, some string of marks, is a term, you can just ask, does this refer to something? Is it trying to refer to a mathematical object? Constants and variables are, but there are also more complicated things that would, like 1 plus 1, or f of x, or sine of theta. So these are examples of more complicated terms. What makes these into so these are not constants. So this is not a constant, and they're also not variables. So what makes these terms is the grammatical rules that we provide to these kinds of symbols. Plus in this case, the parentheses in this case, and in this case. So let's just break one of these down as an example. So when we look at like 1 plus 1, it's kind of like when we were looking at John hit the ball. What made that a sentence was the parts of speech of each component. So here, what makes this a term is the fact that here we have a term, here we have a term, and the rules of plus are such that if you put a term on either side of a plus, then you get a well-formed, perfectly grammatical term. So somewhere in our description of the rules of the grammar of math, we have to say something like this. If you take a term, any term you want, and another term, any term you want, and you stick a plus symbol between them, then what you get overall is a term. Somewhere we have to say something like that. And that's what makes this a term. Similarly, let me erase here. Somewhere we have to say, if you take a term, put some parentheses, and then stick another term inside, then what you get is a term. And you would pronounce this as first term of second term. And that's what makes this here and this a term. So f of x is a term because f is a term since it's a variable, and x is a term since it's a variable, and we have followed the grammar rule described here. And sine of theta is a term because sine is a term since it's a constant, and theta is a term since it's a variable. And we have followed the grammar rule written down here. Okay, so I said there would be 4 parts of speech, and so far I've given you 3 of them, basically. Constants, variables, and terms, which includes not only constants and variables, but more complicated things. And again, I'm only giving you a sampling of the things. In general, if you want to know whether something is a term, just ask, is this trying to refer to something? Terms refer to mathematical objects. They're like noun phrases. So what's the 4th one? So the 4th and last part of speech that we will focus on is proposition. And sometimes people distinguish between propositions and predicates for the purposes of logic, but we're just not going to make that distinction. So for us, proposition is just going to mean a string of symbols that makes a mathematical assertion. So you can think of it like a sentence. So let's look, well, let me box it in so that it looks as important as terms at least. Here are some examples. Something like x equals y. So that's a proposition because it's saying something. It's an assertion. The symbols x equals y, that string of symbols, it doesn't refer to anything. It's not a term, but it's a proposition because it's trying to say something. It could be true or false. So that's another way to think about propositions. They're things that could be true or false. So if someone goes up to you and says x equals y, then you could either agree with them or disagree with them. They have made a claim, right? But if someone goes up to you and says, 1 plus 1, you wouldn't agree or disagree. You would probably respond by saying, well, what about 1 plus 1? You haven't said anything, right? So that's the way I think about propositions. They say something. You could put a period at the end of a proposition and it would make sense. So what about in terms of the rules of the grammar of mathematics? What makes this a proposition? Well, just like plus has this grammatical feature that when you put a term on either side, you get a term overall. Equals has this grammatical feature that if you put a term on either side, then you get a proposition overall. So a lot of little rules like this, like the ones for plus and these parentheses and for equals, need to be put into place. So here's another sort of proposition that we're going to be focusing on a lot later on in the course. If you take a term and another term, and you stick one of these symbols in between, so this symbol doesn't mean anything by itself, but if you stick it in between two terms, then overall you get a proposition. And this is an aspect of the grammar that you can understand just as syntax without knowing what this means. Later on we will see that, as you probably already know, you can read this as x equals y, and you might not already know, or that you can read this as x is in s. So propositions make assertions. They say something. Okay, I want to show you just one more example of a proposition before ending this. So here you see a proposition that's built out of terms, right? There are also ways of building propositions out of other propositions. So let me give you an example. So here's a proposition. Well, here's a proposition, x equals y. Here's another proposition, x equals 7. If you stick an and symbol between them, then the mathematical grammatical rules of and, or the logic, the rules of mathematical logic for and, are such that if you put a proposition on either side, then overall you get a proposition. So here you see a way of taking a proposition and another proposition and putting them together to get an overall proposition. And that's something that and does. Often we will use a symbol. Rather than and like this, we will write a wedge. In our writing, when we write paragraph style mathematics, we will typically use the word and. But they're, aside from stylistic concerns, which will be important pretty soon, they're interchangeable. So whether you write it like this or whether you write it like this, the point to focus on now is here is a symbol which has the property that when you put two propositions on either side of it, it creates overall a proposition. All right, so here is a series of examples. So let's look at each of these strings of symbols and ask, is this a term or a proposition? So here we've got 1 plus 2 plus 3. The rules of plus are such that if you put two terms like this, then putting plus in between gives you a term. So this here is a term, and a term with a plus symbol and then another term gives you a term. This whole thing is a term. So that's one way to think about it, sort of formally following the rules. The thing is, we're not actually... I haven't really given you all of the rules. So there are a lot of things you can say, like this here, for example, and this, where I haven't given any rules, like I gave for plus, as to what is grammatical. So here's another way to think about it. Instead, just ask yourself, does this refer to something? Or does it assert something? Or neither? This refers to something, so it's a term. 1 plus 2 plus 3, that's a thing, so it's a term. If it were to assert something, like this one says 1 plus 2 plus 3 equals alpha. That says something. I could put a period here. It's like a sentence. Then that's a proposition. And if it's neither, if it's not referring to anything and it's not saying anything, then you would probably just say it's ungrammatical. There must be something wrong with it. Everything in mathematics is going to be either a term or a proposition. So going back here, we had two big grammatical categories, terms and propositions. Everything falls into one of those two categories. Every string of mathematical symbols will be one of those two. And yeah. So so let's just do the rest of these. So sine plus 1. So what would that be? At first, you might try to think about the meanings of things and say, well, this doesn't make any sense. Sine is a function and 1 is a number. What does it mean to add a number to a function? That should just return an error or be considered ill-formed or ungrammatical. Well, no. The rule for plus just says if you put a term on either side of the plus symbol, then you get a term. This is a term. If someone says sine plus 1, then they're definitely referring to something. That's because of the plus. When you plus two things, you get something. Whether what they're referring to makes semantic sense or not is a different question. So this could be perfectly grammatical. It could be syntactically correct while making no actual sense. Kind of like our sentence early on, whatever it was, a shoe rack bent the email or something like that. That was perfectly grammatical, just like this is perfectly grammatical, even though it makes no sense. All right. How about this one? So this one, I mean, it looks like a sentence. You could just put a period. Every integer is even. That's an assertion. It's something that could be true or false. That's a proposition. But you might complain, this is not made out of mathematical symbols. So how can we really call it a proposition? It's not part of the mathematical language at all, right? Well, that's technically correct. This is not part of the formal mathematical language. However, we are generally not going to be using purely formal mathematical language. We're going to be using English stand-ins for formal mathematics. And we're going to use English a lot to talk about what's formally happening. So this sentence is a nice English stand-in for, and it's a nice English substitute for something that you could write symbolically. And here's how you would write it symbolically. So eventually we'll have, eventually you'll be pretty good at, reading all these symbols. But for now, I just want to show you that it's often convenient to express things using English stand-ins for the symbols. So what what this is really saying, what actual proposition it is this one. And if you don't want to focus on the semantics, if you just want to focus on the rules of the syntax, then to verify that what you have is a proposition, you need to work with the grammatical rules having to do with all of the symbols showing up here. But since we're not necessarily diving quite that deep yet, I just want you to get a feel for the parts of speech. It's enough to just ask yourself, is this asserting something? Is it like a sentence? Is it something that can be true or false? If it is, then it's a proposition. Every integer is even. You probably believe that's false, right? Well, it doesn't matter whether it's true or false. The fact that it can be either true or false tells you it's a proposition. 1 plus 2 plus 3. It's not that this is true or false. It's not that it's not true, but not because it's false. It's not true because it's neither, right? It doesn't have a truth value. It doesn't make sense to ask whether this is true or false. This, on the other hand, it does make sense to ask whether it's true or false. So now you have learned something about the parts of speech in mathematics. Every mathematical expression, whether you write it in pure symbolic form or using English stand-ins for symbols, every mathematical expression is going to be either a proposition, it's asserting something, or a term. It's referring to some mathematical object. And if you want to break down what are the propositions and terms exactly, well, they're made out of smaller propositions and terms using some rigid rules. And the smallest thing you can get, the sort of atoms, atomic pieces of the language, are the variables and the constants, which are both types of terms. They refer to things, but they sort of have to be laid out at the beginning of the construction of your language. Like, here are the symbols that will serve as variables, here are the symbols that will serve as constants.